Let's look at class relationships in object-oriented programming language. There are four of them: association, aggregation, compositions, and inheritance. These class relationships describe how classes are connected or associated with each other in a program. Association represents a relationship between two classes where one class uses another class as part of its functionality. Sometimes they can be one-to-one, they could be one-to-many, or many-to-many. In the example of a student and course relationship, you could have 5 students associated with 60 different courses to take. This could also be one-to-many. In light of the fact that there are many students in an institution, you could have multiple students associated with multiple courses. These are what we call associations. One example is a car class may have an association with an engine class, or you can have a class associating with a wheel class. Let's look at aggregation, which is a specialized form of association where one class represents a part or is contained within another class. It's basically what we call has a relationship, meaning a car has a wheel or 4 wheels. A car has an engine or no engine. Aggregation implies a weaker relationship than composition that allows the contained object to exist independently of the container. This understanding is a little bit abstract, but this is what encompasses class relationships. One example of aggregation is a department class may have an aggregated relationship with an employee class where an employee belongs to a department. Think of aggregation as has a, as in class A has a B. They may not be associated one-to-one, many-to-many, or one-to-many, many-to-one, but it is through this has a relationship that forms what we call aggregation. Composition, on the other hand, is a stronger form of aggregation where the lifetime of the contained object is dependent on the lifetime of the container. It is a contains a relationship, meaning when the container object is destroyed, the contained object is also destroyed. This is where one class owns another class and is responsible for its creation and destruction. One example of composition is a house class may have a composition relationship with a room class, where a room is part of the house and is created and destroyed with the house. Student and course is definitely not a composition. You can think of this composition as a toy that is made up of a multitude of Lego pieces. That whole toy, let's say an animal toy, consists of these Lego pieces. That is, it contains a relationship. That is composition. Therefore, you can kind of see the differences amongst association, aggregation, and composition. Let's talk about inheritance. This one is definitely more advanced. This is a what we call is a relationship. This is where one class inherits properties and behaviors from another class. We'll look at this is a relationship through inheritance much later. One example is a car class may inherit from a more general or generic vehicle class, inheriting common properties and behaviors such as start, stop, move, etc. Where this vehicle class does not have to be a car. It could be a boat. It could be a bicycle, basically consisting of all of their generic properties and behaviors. Inheritance allows for code reuse and specialization, which is also the crux of OOP. Understanding and properly defining class relationship is essential for designing well-structured and maintainable object-oriented systems. Next, let's focus more on composition. Let's look at this example of student address and name and their relationships. We know that composition contains a relationship versus aggregation, which has a relationship. This composition is strong versus aggregation as weak. What does that mean? Strong as student would have a strong contains a relationship to name, meaning a student must have a name or a uniquely identifiable ID. That is a composition. Student contains a name, whereas aggregation, students may have an address. This could be a PO box or a physical address. So the way that we define composition and aggregation is composition is strong relationship, aggregation is a weak relationship. Let's look at aggregating object versus aggregated object in the next examples. This is an example of student name and address. These are three classes. Notice that a student must have a name, may have address. Therefore, students is an aggregating class, or you can think of it as a container for both name and address. Since both name and address objects are contained, they're called aggregated classes, not aggregating class. Why is this important? It is important because when we model the entire software, a software may consist of multiple classes. We must understand all of these classes and their relationships. Sometimes through these design and aggregation, composition, inheritance, etc., we can draw a clearly defined boundaries amongst these things. For example, if an aggregating class is responsible for aggregating several data fields, these data fields could be of their own respective classes. Then we can decide whether we should have an array, linked list, or any other data structure to encapsulate them. So these things are very important and essential for designing well-structured and maintainable object-oriented systems. It turns out in many textbooks, they don't really differentiate between contains A or composition versus aggregation, which has A relationships. The notion of which one is stronger or weaker is pretty blurred. Just note that aggregation and composition are important because it allows a class to decide on who to contain, who to encapsulate, where the container class is what we call aggregating class. And these has A or contains A objects will be the aggregated class. Let's look at another examples of aggregation. This is an example of defining a generic person. This person could be yourself, an employee. It could be a supervisor. This is an example where a person could have and has a relationship with that of an advisor. We choose aggregation over composition because a person may have a supervisor. Sometimes you have to decide if this person definitely has a supervisor or supervisor is required of all employees in a company, then you would end up with contains A versus has A. Regardless, what we have here is an aggregation relationship. It's almost like a nested aggregation, having the containing object to contain another instance or specialized instance of itself. This is absolutely allowed. Let's look at another example. This is an example where one person may have multiple supervisors. This is what we call one-to-many relationship. Sometimes people use M as in many instead of using asterisk. Both are fine. Notice that we have aggregations here because the person doesn't always have to have supervisor. But if you have a weaker version of aggregation, this means that the person may have one-to-many supervisors. In your person class, you would have an array of supervisors. This type of relationship at design time allows you to have a better judgment in what to do with this particular data field, which turns out to be an array. Let's look at another example involving car and engine, as stated before. In this code snippets, we have two classes. One of them is engine and the other one is car. Both are public classes. A car is an aggregating class, whereas engine is an aggregated class. The reason is because a car has an engine. Technically, a car contains an engine, but not all of the car has an engine. For example, electrical vehicle car would have a battery instead. The relationship between car and engine, as the code illustrates, is one-to-one relationship. And this is a has a relationship aggregation. We don't have many engines, only one. With that in mind, at design time, we can make proper judgments in implementations, noting that there's one engine and we can have constructors to initialize the engine, the models and etc. at object creation time, constructor. We also have the notion of encapsulations, coding these variables or data fields as private, and we use the asterisk methods to ascertain these private data. Object compositions or aggregation allows you to create complex objects with well-defined relationships between their components. This relationship promotes code reuse and modularity, as you can create smaller reusable components such as the engine class and combine them to build more complex objects such as the car class. This makes your code easier to understand, maintain, and extend. This should complete our discussions on the basic composition aggregation relationships in object-oriented programming language, such as Java.